Good morning. Today we are going to see about queue concept. What is meant by queue? Queue is a linear data structure in which the insertion and deletion operations are performed at two different ends. In a queue data structure, adding and removing elements are performed at two different positions. The insertion operation is performed at a position which is known as rear, and the deletion operation is performed at a position which is known as front. This is a diagrammatic representation of queue operations, that is rear end and front end. Here we are inserting the elements in rear end and deleting the element in the position of front end. The queue is working under the principle of first in first out. It is simply called as FIFO. Then there are three operations are performed in queue. First one is NQ, then DQ and display. NQ is the element is entered in the queue is called NQ. To delete an element from the queue is called DQ. So display the elements after insertion and deletion is called display function. To represent the data structure, we are using two implementation. First one is array, then second one is linked list. Queue data structure can be implemented in two ways. Using array means we are already previously know the index elements, that is how many elements we are going to insert, that will be known clearly. The next one is using linked list. In this we have used in linked list, each node contains two parts. One is data part and the next one is address part. Then in queue data structure using array, a queue data structure can be implemented using one-dimensional array. The queue implemented using array stored only a fixed number of data values. That is, we already know how many elements we are going to insert in a particular queue. In queue data structure, just define one-dimensional array or a specific size and insert or delete the values in an array by using FIFO concept. That is first in first out concepts with the help of the variables front and rear. Initially, both front and rear are set to -1. Whenever we want to insert a new value to the queue, increment a rear value by 1, then insert that position. Whenever we want to delete an element from the queue, then the element which is front position and incremented the front value by 1. These are all the steps carried out for that using array. So step 1, include all the header files which are used in the program and define a constant size with a specific value. Declare all the user-defined function which are used in queue implementation. Create a one-dimensional array with a above defined size int queue size. Then we have defined two variables, that is front and rear, and initialize both are -1. Then implement a main method by displaying menu of operations, like make suitable function calls to perform an operation selected by the users on queue. Then in NQ operations, that is inserting an element in the queue. NQ is a function used to insert an element into the queue. In a queue, the new element is always entered at a rear position. The NQ function takes one integer value as a parameter and insert that value into the queue. So check initially, your first step is initially we check whether the particular queue is full or not. If rear size equal to size of -1 means if it is full, then it display queue is full. Insertion is not possible and terminate the function. Then step 3, if it is not full, then increment the rear value by 1 and queue of rear value equal to value. Then we have inserted a new value. So this is the diagrammatic representation of inserting an element in a particular queue. Initially both front and rear are -1. So this is the basic structure of the queue. Then DQ operation to delete an element from the queue. In a queue data structure, DQ is a function used to delete an element from the queue. In a queue, the element is always deleted from the front position. The DQ function does not take any value as a parameters. To delete the element, we have follow the following procedures. First one, we check front element equal to -1 and rear equal to -1. If the queue is empty, we cannot delete any element. If it is not empty, we can perform delete operations. To check whether the both front and rear are equal, if it is true, then set both and front rear to -1, then increment the front value by 1 by 1. So this is the DQ function. Then finally display operation, check whether the queue is empty. If the queue is empty, display the queue is empty. If any elements are present, then present that particular element. So this is the working principle of queue. Thank you.